Can distributed design help us to tackle the food waste problem? Hello, my name is Secil Afsar. I'm an engineer and architect who is focusing on computational design, integrated digital fabrication technologies of green biocomposites to design and build regenerative urban systems. Currently, I am working at IAC as a fabrication laboratory assistant. Today, we will challenge the question of what is a waste and try to answer this question from a designer, artist, or maker perspective. Actually, we will try to talk about the specific type of waste, which can be seen as more innocent compared to other chemical or industrial waste. This is food waste. Food waste creates 26% of the total green gas emission of the world yearly. And unfortunately, 1/3 of the total food production goes to waste every year. There is a great deal of food thrown away each year, but they are not thrown away because they are expired most of the times. They are generally discarded by us because they are not visually appealing or their texture is not giving us a pleasure anymore. Maybe in the times of our grandparents, it's not that much. We don't have that habit that we throw the foods that much easily. They always have the tendency to recook from the old foods. For example, they were making crunchy breadsticks from the old breads or boiling discarded peels with the sugar to create syrups or cooking soup from the remaining food broth. In addition to this upcycling techniques, when we mention about the visual appearing and the texture of the food, and when we talk about the texture problem, and we can define this texture problem that maybe like a banana that go bad or apple that's not that much seems delicious but still contain lots of nutrients inside of it. We can, with the 3D printing, actually we can design micro and macro structure of the foods to make them again attractive for us and kind of developing this process by the help of makers, designers to carry in our daily life. Let's dive into a bit more the 3D printing food technology. Actually, this technology works similar to 3D printing process, but instead of using materials like plastic or metal, it uses food ingredients as a printing medium. In 3D printing, food ingredients are loaded into the printer, often as a pured or paste-like form. And it's as the other traditional FDM printers, the material extruded layer by layer to construct the foods in desired geometries following the digital design. The process allows us the creating shapes and textures might be difficult or impossible to create by hands. A wide range of foods can be printed with this technology, for example, chocolates, pastries, or various types of dough. One of the key benefits of 3D printing food is the ability of customizing the food items in terms of shape, texture, flavor, or nutrition. If we want a little bit detail about this process, for example, some people need some specific dietary requirements, or some elderly people having a swallowing issue. In that scenario, for the elderly people who can have a swallowing issue, creating like a texture that they can easily chew and eat can help to proceed their taking nutrition. Let's look at some example projects and products in the market who are focusing on different advantages of the 3D printing process, as we mentioned. For example, Barcelona-based company Novameat uses the advantage of 3D printing micro extrusion process to create plant-based steaks. So they are mimicking actually the whole cut of the steak by creating muscles and the fat of the meat that people like to eat, but from the plant-based resources, and adding the specific nutrition that we need to gain from the meat products. Also, there are other Nordic company called Chamorro Food. They developed the fillet product. They are mimicking the taste and the texture feeling of the salmon with the same process of micro extrusion as we mentioned about the Nova meat. Furthermore, when we talk about the macro design of the 3D printing food, Netherlands-based company Upcycling food, they are collecting the fruits and vegetables that they not visually appealing and mixing with the old bread to create like a paste, like dough, and printing with this dough as a layer by layer process and making a shape that became more attractive and appealing. Also, during my internship in Fab Lab, I was lucky to be part of Cisco and food tech projects. Also, I was working on a past extrusion process of the 3D printing food by collecting fruit and vegetable peels. Also, the peels that we discarded are most of them are edible, but because of the texture and their bitter taste, we don't like to eat them. And by creating healthy snacks, we can reuse the peels, upcycle the peels, and carry back to our tables. The project is focusing on using the local waste and collecting the peels with the cargo bikes from the local shops and bringing to the kitchens to print with these discarded foods and carry them back to these local shops. Let's summarize the process line of the 3D printing food very simply. And as we mentioned, this is kind of look like the cooking process, but we need to have specific viscosity and consistency of the material in order to extrude it. That's why while we are developing the taste of the food, we also need to think about the materiality of the food. We mentioned some of the projects. Also, one of the projects that I developed in 2019, the idea was to upcycle fruit and vegetable peels. And the process actually same with the preparing a dough as we did traditionally in our kitchen. However, this time we need to also consider not only the taste of the cookies, but also the consistency of the cookies to make it printable. When we collect the discarded fruit and vegetable peels, before we are processing them, we need to brush them with under the water softly. You can use simply your toothbrush for this process too, because during the farming process they can expose to lots of chemicals. After you peel off and wash the peels, you need to make them as small pieces. You can use like a blender to make this process. We are doing this because when we extrude the material, the nozzle sizes can be, if the nozzle size is small, the resolution of the food is more clean and you can develop more complex shapes. That's why if we have a big grain size of the peels, it can stuck the nozzle to prevent material to flow smoothly. That's why we need to make them as small as possible with using some type of, it can be hand blender or it can be like a shaker, as I show you like that. And we need to mix it with the flour and the butter as a traditional cookie that we use. Also, to create the consistency and to keep the cookies together after baking, we will add some eggs to this recipe. Actually, each ingredients have specific roles in this material development. For example, if we look at each process, as we mentioned, the flour can be, it's a starch-based generally starch-based product, and they can be used as a thickening agent to retain shape after the deposition and to facilitate the extrusion of the food materials. All-purpose flour is generally the most popular starch-based flour, but if you are vegan or if you are preferring the other types of flour like oat flour, you can go with this type of flours too. And the other thing to create the results in more like chewier and to make more cohesiveness, we can add butter in a melted way. The vegan alternative, we can replace this butter with the coconut oil or other food ingredients as you prefer. As I mentioned, egg in that case is very important to create the binding properties of the dough. But if we add too much egg into the dough, this time we will struggle to extrude the material. That's why even in the normal cookies we can play with the egg amount. Generally, we have different types of FDM 3D printing food techniques. One of the most common ones is the past extrusion. So in this thing, the material is deposited from the cartridge with the help of the air or other force, and the piston directly push the material out of the nozzle. And the other type of extrusion techniques, which is more popular in ceramic or other type of biomaterial printing, is the screw-based printing. In general, in the food printing industry, I see more this cartridge-based or syringe-based extrusion techniques, but the advantage of using screw, you can actually follow up how much material you deposit by controlling the rotational speed of the thread. Before placing the food paste inside the cartridge, it's always good to test the consistency and the extrudability of our material. For this, we can use the simple syringe and see by hand if we can extrude the material continuous way. And if we see that material is falling apart and you cannot extrude good, maybe you need to add a little bit more butter or a little bit more egg to play with the consistency. And the important thing is inoculating the material inside the cartridge is always you shouldn't give any air gap to the process, because while printing, if you give any air gap, the continuity of the print will be damaged and there will be some holes in your geometry. That's why while preparing the material is very important. The inoculation process of the material, the arranging the extrusion rates of the material and the print speed, they need to be all well calibrated. Actually, we can think this as a multi-parameter process. You need to think about the nutrition of the food, you need to think about the material properties of the food, and you need to think about the machinery process of the food. However, if we consider the uncountable advantage, as we mentioned, in the both industry or also our daily life, we should well calibrate it and make this process line together to carry in a better way.
I'm Eduardo Chamorro, and I'm going to explain to you how we're going to use our biomaterial and paste 3D printer that we hack and produce here. So the first thing we're going to need is, of course, the printer itself, a computer, and a cartridge full of material. We need to produce some material to use it. So we need to take out the cartridge that we're going to fill with material. So we have prepared here some little tools like industrial cookie or bread mixer, some spatula, a weight, some glycerin, Shanton gum, basic materials for making really simple biomaterial for this test for today. And let's start mixing. So let's put off ourselves some nice black nitrile gloves. We know exactly the total amount of material that comes in these containers. The formulation changes a lot on what you are doing, but you always want to have a little bit of quite toothpaste thick consistency. Now that we have here the base biomaterial, we're going to start adding some glycerin. For that, I'm going to take a scale and weight, xanthan gum, glycerin, let's put some nice 50 grams of glycerin in this case. Let's weight this spoon and let's take some 10 grams of xanthan gum. This will work more or less for half a mixture of most of the biomaterials for 3D printing. Yes, exactly. Okay, so we will need a little bit of water, but let's put at first speed to mix everything. Water from Barcelona, local water. And let's leave it like this for a while. So now that it's shaking and all the dough has been mixed properly, let's stop it. Done. Let's open it. And let's put the dough in this little container that we have here. And let's check the consistency. It's nice because it stays like one single block. It has kind of a ceramic or soft clay consistency and has a good cohesion. This is thanks to the xanthan gum. So it seems like a good mix. We will see. Sometimes we need to readapt a little bit the mixture, but for now, let's start filling up the cartridge. We have two caps. The start we will connect to a extruder system. The blue cap that we can unscrew it. And watch out because in the inner part there is an O-ring or a rubber ring. It's important not to lose this because it helps for creating the seal for the air pressure. Then in the other side, sometimes it's a little bit difficult to take it out, especially with gloves. Yes, sometimes work. If not, you can use a little bit of air compress to take out the piston. So now that we have the dough in a plain state, what we're going to do is fill it up. We don't want to fill it by hand because they will create a lot of air gaps and air pockets inside the mixture that will later also create some explosions that will not give us a nice print. So we want this to flatten the mixture nicely and push it hardly until we reach the end of the pocket. Then we turn the cartridge. We'll do it for you. Let's see if I can. And kind of we make dog nuts and we mix again our mixture. And we repeat again, over and over until we have the container completely mixed. The mixing technique of the cartridge is key to get a good print and a good quality print. So it's important to don't make any bubble gaps or air trapped into the mixture. Sometimes where the cartridge starts to get quite full, becomes slightly more difficult, but don't stress, just a little bit of patience and you will get it solved. Now we need to insert the piston. This hold well your cartridge, push from the back and press it. Now clean well the thread and put the cap, thread the cap. It should come up nicely and smooth inside. If not, it's because you have not aligned the cap properly for the cartridge. Now it's time to jump onto the printer. Now the whole system is assembled, but we want to show you how to disassemble, assemble, so you can use it and clean it completely on your own. So first thing we're going to check is that the machine is completely turned off and let's disconnect it from the power supply. You will see that the screen still keeps on for a while, until actually it gets all the electricity sucked down by the electronic board. So now that it's completely off, we're going to start disassembling the cartridge. So let's turn counterclockwise to unscrew it, so the cartridge is completely out. Basically, we replace the extruding FDM head for a standard FDM 3D printer as this Creality Ender 3, a custom end effector with a extruder motor and a pressure system that will help us to push and dose the material evenly. You will see nicely that we have different nozzles, so you can change the nozzle type, so we can easily swap. So the system that we have produced actually is just mounted by 4 bolts. One here, just on the bottom, on the left, and a little bit on the top. So with a standard 2.5 Allen X key, we can unscrew them. The extruder can fall, so hold it with your other hand. And we have our extruder in our hand. What happened? The motor is still connected to the printer. So disconnect the connector, and you can completely take it out. There is a motor and an inlet for the material and the nozzle out. This system is composed of still two components. The motor, you can screw it to clean it, doing some maintenance, or just in case your material got jammed inside because it's too dense. We can see the screw that actually will dose all the material. Watch out with this screw because it's quite thin and it's slightly fragile. As you see, right now there is an adapter plate that will help you to locate 4 screws at 40 by 40 distance, so it's equal, and the weight of the whole extruder and everything is evenly distributed. We are mounting the screws in diagonal. You always mount in cross because that will help to center all the system and distribute the load and the stresses among the material. So let's put the connector. Hooray, already. And let's screw clockwise, gently, the cartridge. It should come in completely smooth. Be sure that the cap is sealed. In here we have our air compressed pipe. In our case we have a valve to open the system and an air gauge to tell us the pressure. So let's put the connector on top of the cartridge. This cartridge is rated to a maximum 6.5 bars. That means we cannot use it at more if we want to be safe. Normally, different biomaterials have different pressure range for printing. Even ceramics, depends on the water content that you mix your clay with. It's always good to start in 0 and start increasing the pressure until you see that actually the material gets compressed and the piston moves the material down completely. We have our gauge at 0. We're going to open the valve. You see the system pressurizes a little bit, and we're going to start rotating clockwise until we see that the gauge is increasing. 1 bar, 2 bars, 3 bars. We know already that this mixture is going to be printing really well at 4, 5 bars. Let's keep it at 4.5. Okay, so now it's time to connect the machine to the computer. For it, we have a mini USB cable that is connected to the machine and a standard USB that goes to our computer. Our choice of program for controlling the machine is Repetitor-Host. It's an open source program that allows to control the machine, move it in X, Y, Z, move the extruder to extrude a little bit of material, and also allows us to put the G-code file of the file that we're going to print. So we need to click on Connect. If the machine is not connecting properly, you will see, because you will not see that the machine is not resetting, as you will see in the LCD screen. In that case, you might need to install the drivers for compatibility on your computer. Now we're going to jump onto controlling the machine. We're going to move up the machine, moving Z up. And what we can do is extrude a little bit of material to check that the machine is loading the material properly. We can see that right now we are making a starch potato spaghetti coming out, and that's nice. Let's home the machine. It will find the origin set point for the X, Y, Z axis. We can cut the potato and starch leftovers of the extruder, and we can launch our file. For that, we will go onto print preview, edit, decode, and we're going to paste the lines of the code here. I have already made up this file with a custom grasshopper component where we also have like a setting for Cura and other slicers. So in our case, we will paste here the G-code file that we have created with, in this case, with Grasshopper, but we also have a compatibility for Cura and other slicers that we have made to make it easier. And now we can just click Start Print to start printing, and we can see that here on this side we have the feed rate to overrate the speed and flow rate to overrate the total amount of material that we are printing. Right now we are printing the base, so just a small cup, it's a circle. Usually the first layer is the one that looks quite ugly, but the second one is there for helping on the aesthetics and also for increasing the stability. You can see the line that we are printing exactly on time.
To wrap up the process, I would like to ask you some questions. For example, the initial topic that we talked, are you upcycling your food? Do you have any memories from your elderly parents that they use some techniques to develop this upcycling habits? Also, in the modern times, do you think 3D printing can help us to carry this habit to spread this habit across the world? And would you like to prepare your own recipe, a cookie recipe, and manipulate little by little your butter and flour amount to create your own 3D printable paste? Even you don't have the know-how of developing digital design, or you don't have the machinery, maybe you can buy simple syringe and to create your own shape on the some cooking paper and the test and try if it is different taste and texture compared to your everyday cookies.